Theoretical recap. On Debian-based Linux systems, /var/log/auth.log records authentication and authorization events, SSH connections, successful and failed, sudo invocations, su attempts, PAM messages, and session open/close events. On RHEL-based systems, the equivalent is /var/log/secure, and journaled may also hold these entries, journal.ussh. The mental model to adopt. Auth.log is a chronological, append-only text stream where each line follows the pattern timestamp hostname process PID message. Detection work means turning this raw stream into signals. Repeated failed password lines from the same IP indicate brute force. Accepted password or accepted public key shows successful logins. Sudo command equals reveals privilege use. Invalid user points at username enumeration. A clear example. The line failed password for invalid user admin from 203.0.113.5 port 44921 SSH2 tells you an attacker tried a non-existent account from a specific IP. Count these per IP and you find your attackers. Common mistakes. Forgetting the file requires root or the ADM group to read. Parsing timestamps naively. syslog format has no year. Confusing invalid user with a valid failed login. Using overly greedy grep patterns that produce false positives, and analyzing a rotated/truncated file. Check auth.log.1, auth.log.2. Gs with screp. Keep detections reproducible. Prefer scripted, documented commands over ad hoc one-liners you cannot repeat. Workshop brief. Your goal is to build a small detection toolkit that scans /var/log/auth.log and its rotated archives and produces actionable security findings. You will combine the bash scripting, cron scheduling, and logging concepts from your recent chapters into a working detection script. This is both a technical exercise and an analytical one. You must decide what constitutes a genuine detection versus noise, and justify your thresholds. Start by exploring the file manually. Read a sample, identify the distinct event types present, and document at least 5 patterns worth detecting: failed SSH logins, successful logins, invalid users, sudo usage, and one of your own choosing. If your test machine has little traffic, generate events yourself. Attempt failed SSH logins, run sudo commands, and create /su to a user. Building your own dataset is part of the task. Next, write a bash script named auth_scan.sh that parses the log and reports, at minimum, the top offending source IPs by failed login count, a list of successful logins with their source and timestamp, all invalid user attempts, and a summary of sudo commands executed and by whom. Handle rotated logs with screp so history is not lost. Your script must accept an optional threshold argument. For example, flag any IP with more than n failed attempts, and output a clean, human-readable report to stout and to a timestamped file. Then make your detection operational. Schedule the script via cron to run periodically and append findings to a dedicated report location, applying the log rotate and journaled knowledge from your previous activity so your own output does not grow unbounded. Consider what alerting would look like. How would you flag a brute force in near real time? Finally, analyze and interpret. In a short written report, Markdown, present your findings from at least one dataset, explain your chosen thresholds and why, list the false positives you encountered and how you reduced them, and describe 2 limitations of log-based detection, and how an attacker could evade it. For example, log tampering, low and slow attacks, distributed source IPs. Deliver auth_scan.sh, a sample report file, your cron configuration, and your markdown analysis.